Hello, community! Attending a conference is great because you notice what people ask you. So let's talk about here DSPy. If you are not familiar with this, DSPy is a self-improving machine learning system. And I got a lot of questions how it is compared to in-context learning, plus with our many-shot in-context learning capabilities of our new LLM with a 1 million token context length. So here we go. If you want to learn about ICL+, I have a video on this. But DSPy, let's focus on this. Now, DSPy today has got a new name interpretation. Today it is called a Declarative Self-Improving Language Program pythonically. And you might say, what? So let's start from the beginning. DSPy originated here from DSP in 2022. And the idea was simpler. The DSP stands for Demonstrate, Search, and Predict. And it was at the time a framework that relies on parsing natural language text in sophisticated pipelines between a language model and a retrieval model. So you see here we focus language model, retrieval model, and the building and optimization of pipelines between those models. This is the origin, and this is the key for you to understand DSPy later on. Because of course it evolved over the years. If you want to understand Demonstrate, Search, Predict in a second, let's try this one. This DSP framework was used in context learning. So you see here, this has its origin in ICL. At the time, in 2022, they started here with an input question to be solved by the LLM and a two-shot training example. So we have a question and a two-shot example where we have a question and the answer that we like, and another question, another answer that we like. And this was our training set. And then our DSP introduced a number of composable functions that bootstrap now new training examples. And this process they call Demonstrate. And what they done is simply by decomposing here the query, our question here, into, if it was a complex query, into 3 smaller, less complex subqueries. And for those subqueries, they gather information from a different knowledge corpus, they did the search operation, and then for the simpler questions and all the information on the simpler questions, they started to generate or predict now a more complex output. So you see, this is the idea of DSP that later moved on to become DSPy. But this gives us here an insight you should always be remembered when we talk about DSPy. At the same time, you see here that Omar, so the identical person from DSPy, also did some research on ColBERT. This was simply here, you remember, BERT in the 2020s. And then 2 years later, you have here the publications from Stanford University, also with Omar, where they were talking about efficient retrieval system. So I told you it is about the language model and the retrieval model, and the information retrieval between those two models. This is where DSPy evolved, originated. Now, ColBERT version 2 is something beautiful we use today. For my green grasshoppers, here I explain what is ColBERT, especially version 2. You have your query and your text passages. They're independently encoded here with the classical BERT. And the output embeddings encoding each token are projected here to a lower dimension. And during the offline indexing, every passage D in the corpus is encoded into a set of vectors, and these vectors are stored. And at the search time, when we get here our question, the query Q is encoded also in a multi-vector representation, and its similarity to our passage D is computed as the summation of query side maximum similarity operation namely the largest, for example, cosine similarity between each query token embedding and all passage token embeddings. Plus, there's a clever idea utilizing here our residual compression technique, where each token embedding vector is encoded by referencing a set of pre-computed centroids, thus storing only the deviation from these pre-computed centroids. So there are a lot of clever tricks they use here in ColBERT version 2. Now, there is now a beautiful difference. With 5CL Plus, our many-shot in-context learning, when we have 1 million token context length up to 10 million token context length with the new Gemini programs, LLMs, we have here simply one prompt. But DSPy is now a machine learning framework. It is a machine learning system. And with every machine learning system that you know, when we fine-tune an LLM, you know what we have. We have a loss function, we have an optimizer, for example, an Adam optimizer, and we then let the system run, compile, and get trained. So all our weight tensors are now optimized for a particular task. And the same we have here. DSPy has its training set, its development set, and the test set for its performance evaluation. And this is the crucial word, a self-improving machine learning system. So whenever the system is self-improving, the system has to run one cycle, analyze what have I done, try to improve myself, run another time, look what have I done, is it better, worse, self-improve again, run the complete system. And you understand that this is completely different here from a simple many-shot prompt example in context learning. Therefore, DSPy, as it is today, we have a declarative self-improving program in Python, PyTorch, and this program more or less lives exactly between our language model and our retrieval models. And now this in between we call a pipeline. Beautiful. So DSPy, machine learning framework, you have a training set, development set, test set, and it is a self-improving machine learning system. And now you understand when we talk about DSPy, is a programming model designed to streamline here the development of the optimization of pipelines, language model pipelines for complex tasks. And we have more or less 4 elements in our program structure. We have signature, modules, teleprompters, and compiler. Now, signature, if I tell you that this is here a declarative program structure, you know, signatures abstract here the input-output behavior of our modules that live inside of the pipelines. So signatures, input, output, they just tell you what to do. Modules are now critical elements here because they replace here the traditional prompt templates that you might know from LangChain with functions, but these functions are parameterizable functions. So you see here modules, submodules, different models combine, and you get already the idea. And then we have in DSPy teleprompters, a very strange word substituted with an optimizer, an optimization tool to automate the prompting process within our pipelines. Similar to an Adam optimizer if you want an analogon. And then, of course, you have to compile all of this into machine readable code, executable code, and this is done by a compiler, and it optimizes here our pipelines based on a metric you can define. Metric can be accuracy, a specific metric that you need for your task, whatever. And this now enhances here the quality and the efficiency of the program. Let's go for a very simple example. Now we build here, or we test here, a simple pipeline configuration. And as I told you, DSPy is here in the interface between language model and retrieval model. So what do you think we go here with a reg functionality? retrieve, augment, and generate here from external data sources. Now, remember in DSPy we have now two things. We have our pipeline. In this pipeline, we can build the pipeline the way we want it. We can have a single modular structure, we can use multiple modules, we can have a multi-modular structure, we can have sub-modules in our multi-modular structure. It's like a Lego. You can build whatever you want in your pipeline. But remember, those modules, they are here with parametric function, the I/O process, in each and every model, and of course the complete pipeline that is built of our modules. So always remember that we optimized later on when we do the compilation here and we do the runtime, we optimize the structure of our configuration of modules, plus we optimize here the specific parameter, the specific parametric function of the pipeline, which you could also call here the prompt structure. Beautiful. Easy example, we have in DSPy here a specific module. It is called retrieve. And this module has been built for you. And as you can see here, you say from DSPy retrieve, and then you go to specific vector databases, Milvus, Chroma, DB, or Azure cognitive search functionalities you activate, whatever you want. So we have here some pre-built systems for us where we can retrieve here our external information. And if we build now the RAG pipeline, for a simple example, we have here the class RAG. This is of course a DSPy module. We initialize it and we have here two submodules that we need. Of course, we need the DSPy retrieve functionality because we want to retrieve this either from a simple data set or from some external data on databases, vector stores, whatsoever. And then we want to give the system kind of an intelligence. So the second submodule we need is a chain of sort. So this simply tells the system, hey, think step by step with all the information you retrieved and try to make sense out of it. That's all there is. And then you just generate or predict here the answer, given you have now the context and a specific question. Great. After we build our RAG pipeline, now comes the interesting part. Because we have done a programmable structure, we can now run here this and optimize automatically here our RAG pipeline. So what we need for this, we need a training set, development set, a test set, so we know, we understand where we want to go. If I say we want to go, we have to do some validation on a specific metric that is particularly chosen for this task. So you go, for example, with accuracy. And if we have the data, we know what we want, we now have the question and the answers, we have a metric for the validation, then we just need here a DSPy compiler, and this compiler includes here a number of tailor prompters, or as I told you, optimizers for your new DSPy program. And this here is simple to an Adam optimizer when we fine-tune our LLMs. So we let this run, and you see now why it's a machine learning system, because it is quite similar if we fine-tune now our LLM. But remember, we have now the structural component of our pipeline and the parametric component of each module and the complete pipeline. Oh, sorry. Yeah. For those optimizers in the original literature I just found here, yeah, you can start with 10 examples, but having, as the authors write, 50 to 100 examples, or even better, 300 to 500 examples. This will help you a lot to increase the performance of your pipeline structure and the prompt engineering. So 300 to 500 examples, keep this in mind. Now, pipelines you can build like Legos. Why not do a RAG module 1, a RAG module 2, and a RAG module 3, and maybe you go here to database 1, database 2, and database 3. And then you just build another module, and this is already pre-built for you. You go with a majority vote module. So If the result of the first retrieval is 17, the result of the second is 24, and the result of the third is again 17, you know what the majority vote model is? It says, hey, we have 2 times 17, so I suppose this is the correct version, and the job is done. However, you know, of course, that sometimes model generate the wrong result, multiple times the wrong result, so this is in no way helpful at all. To make it even simpler for building here your pipeline, you go here with the parametric knowledge of our large language model 1 to the parametric knowledge of the large language model n+1. Use 3 different LLMs. Use ChatGPT, Claude, and use Gemini or whatever you want. And then you do a majority vote on this. You see, your possibility to build your pipelines are almost endless. You can build your own module in code if you want. It all depends on your specific task in your specific domain. Beautiful. Yeah, if you want a little bit more advanced, they have pre-built modules here, for example, for React. So where you have a tool used so they can go out and do something. Maybe they have a Python environment to calculate something. Or it is simply that they can go and connect to some external data server. Or you go here with a self-reflective RAG, where the RAG does its work, and then comes the self-reflective part of the thing, where the RAG thinks, is this correct? And the RAG itself tries to make sense of this, what it retrieved, this kind of information. And then you can add a chain of thought with a hint. And I thought, okay, I know what is chain of thought, but what is with a hint? Now this is easy. I show you here the code. So you have here classic question and answer data set where you have your question, where you have your answer. And then if you activate here this particular chain of thought module with a hint, you're not going to believe this. So when you say, hey, what is the color of the sky? This is your question, and you provide an additional hint to the system. And the hint is, it is what you often see during a sunny day. If you look upwards towards the sky and you say, wow, this is so intelligent, beautiful. So you see a lot of modules for you to do. You can build your own Stanford NLP, DSPy, a beautiful GitHub repo for you. Again, this chain of thought teaches the LLM to think step by step. This is all there is to it. Just go step by step. You can type this down or you use this module. So in this module here, DSPy module, extend here the signature to include additional reasoning steps. Like your domain is in physics or mathematics, you need some logical structure in your argumentation. The way you do it is, here's the class definition of the chain of thought. And you see here, reasoning, let's think step by step in order to uncover something. For my green grasshoppers, a very simple example. When would you use DSPy? How would you use it? For what job would you use it? Now, let's say we have our new GPT-5 system, our vision language super model finally out. And I want now to find here the best prompt for scientific summarization of scientific texts of hundreds of pages. But I want to do this in the style that I like, in the way that I like that a summarization is done, on the domain knowledge that is included in my system. And I don't know the behavior of GPT-5. I have no idea about it. So I take here, for example, here, my old GPT-4 prompt plus 20 summarization example of GPT-4. So this shows exactly, I have here the complete text and then you have here my summarization that I like. So here I give it the system 20 examples here, the DSP dataset, and then have given it here the original prompt, all the example, and I say, now start system, self-improve here yourself with the new operational large language model. This is now GPT-5. Evaluate this LLMs. Of course, you need to have a system that you know, that you trust. We use here GPT-4 Turbo, the classical system now. You define a metric for your evaluation. I can say, hey, it's a more dense, more concise, more interdisciplinary focused summary given here with new insights in physics and mathematics, whatever you want. And then simply you let it run for 100 turns. So the system builds now on your GPT-4 prompt, does some alteration based on its parametric knowledge, comes up with a new prompt structure, with a new sub-prompt structure, modifies it, and after 100 runs, you know that you have achieved now with this particular prompt, number 100, for example, the best evaluation result given your particular metric on your particular domain. So I have now, after paying I don't know how much money to GPT-5, but for 100 runs, I have now my new optimized GPT-5 prompt for my summarization in my style on my multidisciplinary scientific text documents. So you see, GPT-5 will have new insights, new options available. I could try this out myself, but I don't want to wait, so I let the system do the self-learning. I just have to pay for using here GPT-5 100 runs, and then hopefully the system found not just a local maximum, but a global maximum for the prompt structure. Now, let's go back to ICL+. You remember that I told you, now with this 1 million or 10 million token length, we can add a lot of many-shot examples. And in my video I showed you, hey, we can add to 500 examples here. And then, let's stay with this. I have here my old GPT-4 prompt in pink. And then you can say, hey, in this prompt for ICL+, hey, GPT-5, given that I have showed you now 500 many-shot examples here in my preferred summarization style, and I've given you my old GPT-4, my best GPT-4 prompt for summarization, your task is now to find the best new prompt for yourself for, and now if you want, this is now the metric, for a better and a more concise scientific summarization of complex interdisciplinary texts, documents. And then I could add, try 3 times to find a better prompt and show me the result. And you see, you could do this if you type this yourself, or you just let the system run and experience this itself. It kind of depends on the money you have available. So you see, this is quite a dynamic machine learning system. And please do not say that DSPy is only a prompt engineering tool. It is much more than this. So to show you here for my green grasshoppers, where is this self-improving happening? And I go here with 3 steps. And at first we have here the DSPy modules. As I told you, they are parameterizable. They can learn and adapt their behavior over time. The learning occurs through the use of demonstrations, as I've showed you here in the original DSP idea of 2020, examples of input and desired outputs that the system collects and analyzes and learns, and then iteratively processes this demonstration. Now the program DSPy modules can then refine the strategy for prompting or for fine-tuning. You don't just have to prompt here, you can also change here the fine-tuning. You find different parameters that you try out in your loop that you do the evaluation, and you apply reasoning techniques and whatever. So those modules operate, gather, and learn here from the demonstration. And this modularity of the DSPy pipeline is one of the beautiful things here. But of course, we can also have here the dynamic optimization here with our teleprompters. You remember, simple idea, just optimization tools to automate the enhancement of our pipelines between our language model and our retrieval models, or even more complicated pipeline structures. They evaluate different configuration and strategies by simulating here a pipeline with a small set of training examples. So whatever you let DSPy learn and have then inherent knowledge about the configuration of the modules and submodules in your pipeline, the better the system will be. And of course, the last one, the compiler-driven improvement, the better your compiler. Yes, you know it. If you have a metric, accuracy, efficiency, whatever will be, it will be here the perfect compilation. So if you now get a little bit interested and say, hey, I would like to try this out, now that I understand where it comes from, for what it was designed, how it evolved over the last years, where the authors think in Stanford now that it is now a self-improving machine learning system, so can I use it now for my task, for my work, for my company? Let's go there and you say what optimizers are currently available for few-shot learning, for instruction automation, for fine-tuning. Yes, you let the system run, 100 different fine-tuning cycles, and then you find out where the best hyperparameters are available, or for program transformation. Those are available today for you, or Ensemble, of course, and they also answer here in the official documentation, and here you have the link, which optimizer to use in what particular place. And they say if you have very little data, 10 example, you use this particular optimizer. If you have 50 example per task, we recommend that you use this optimizers. And you have more than 300 example, use this optimizer. So I think it's quite easy. Then of course here the modules. I have showed you almost all. We have our predict, we have our chain of thought, our program of thought for code, our react, and then we have a multi-chain comparison. You remember lang chain and all of this? Now you build multi-chain comparison, chain of thought. And I've also shown you here the majority vote system. Now you're familiar with this. And for the last part, I have to show you here the signatures. What signatures do we have? Well, input-output. If your task is question answering, you're not going to believe your signature is simple. Question to answer for sentiment classification. Sentence to sentiment or paragraph to sentiment or whatever you have, and you have a document summarization task, document to summary, or you define it whatever you want. If you have multiple input output fields, like for reg answering, you have a context, you have a particular question, and it will generate the answer. Or if you have multiple choice answering with reasoning, you have questions, you have 3 choices, you have the reasoning part and then the selection part. So you see, as easy as could be. Why not give it a try? Build your pipeline for your particular task. And I hope with this very short introduction to DSPy, you are able to build the perfect dream system that will do a self-improvement of your complete pipelines that lead into or exit your large language model to improve the performance of your LLM and of your complete AI system. I hope it was a little bit interesting. I hope it was a little bit fascinating. And it would be great to see you in my next video.